A 3-phase 11 kV 50 Hz 2-pole star connected cylindrical rotor synchronous motor is connected to an 11 kV 50 Hz source, and its synchronous reactance is 50 ohm per phase, and its stator reactance is negligible, and the motor has a constant field excitation at a particular load torque. Its stator current is 100 amps at UPF. If the load torque is increased so that the stator current is 120 amps, then the load angle is, first, as he mentioned, it is a synchronous motor. So Vt is equal to 11 kV. As it is a line, we have to convert into the phase voltage, as phase voltage is equal to 1000 by 6350.8, and he gave reactance is equal to 50 ohm per phase, and stator resistance is neglected, means armature resistance is neglected. Motor has a constant field excitation, means EF is constant. As he mentioned here, it is a motor has a constant field excitation. So induced EMF, as EF is constant, even load changes, induced EMF magnitude remains same. Now let's take the case 1. Case 1, IA1 is equal to 100 amps, cos pi is equal to 1, which is unity power factor. Then we have to take EF is equal to root Vt cos plus Ia Ra whole square plus sin pi plus Ia. Here it is, as it is a unity power factor, it is 0. Armature resistance is negligible. As he mentioned, it is a stator resistance is negligible, means armature resistance is negligible. So Ra is equal to 0, means Ia Ra is equal to 0. Now we have to substitute the values. 6350.8 into 1 whole square plus 100 into 50 whole square, which is 8082.90 volts per phase. Now let's take case 2. Here we use same EF value because he mentioned that excitation is same, constant. Here in case 2, as load torque increases, Ia is 120, and as we know, he gave EF is constant. So first take, when load is increases, then armature current Ia will change, means first let's take as load torque increases. He gave as load torque is increases, means armature current Ia will change, load angle delta will change, then cos pi power factor will change, active power P will change, reactive power Q is also change. So we can't use previous values because all these values are changing. We only use EF value because he gave it is constant. Now the EF is equal to root Vt plus Vt cos pi plus Ia Ra whole square plus Vt sin pi plus minus Ia xs whole square. As armature resistance 0, so this value will be 0, and squaring on both sides, EF square is equal to Vt cos pi whole square plus Vt sin pi plus Ia xs whole square. As it is a plus or minus, plus is for leading and unity power factor, minus is for lagging. In this case, synchronous motor, if the machine is already UPF, here it is a UPF, unity power factor. Now if the machine is already at UPF, if mechanical load increases, then new power factor will be lagging. In synchronous motor, here machine is already VT is at unity power factor. Here VT is at unity power factor. So this IA1, this IA2, this IA3. As it is a synchronous motor, it is leading, it is lagging. Lagging means negative we have to use here. If it is a synchronous generator, then it is reverse. It is leading and it is lagging. Now as it is a lagging power factor, we use negative sign. Vt cos pi whole square plus Vt sin pi minus Ia xs whole square, as EF square is equal to Vt cos pi whole square plus Vt sin pi whole square plus Ia xs whole square minus 2 Vt Ia xs sin pi. Now EF square is equal to Vt square plus Ia xs whole square minus 2 Vt Ia xs sin pi, because cos pi square plus sin pi square is equal to 1. Here substitute the values. 8082.9 whole square plus whole square is equal to 6350.85 whole square plus 120 into 50 whole square minus 2 into 6350.85 into 120 into 50 sin pi. By substituting all these values, we get sin pi is equal to 0.144, and then cos pi we got 0.989. Now we have to find the new angle. As new power factor is 0.989, we know the power factor angle. Now we can find the active power P, which is 3V phase I phase cos pi is equal to 3 into 6350.8 into 120 into 0.989, which is 22611.634. Now using this active power, we find the load angle delta, which is P is equal to 3 Vt EF by xs sin delta. Now 6350.8 into 8082.9 by 50 sin delta. As we get sin delta is equal to 0.734, delta is equal to 47.23 degrees. This is the load angle.